Hi folks, and welcome back to Math with Captain Rod. The purpose of this video is to demonstrate how to calculate volumes created when you take surface areas and revolve them about various axes. So what we're going to do here, we're going to look at the curve y equals x squared, and we're going to focus on the area bound between that curve, the x-axis, and x equals 4. And we're going to try to calculate the volume of the bound area, the volume you get if the bound area is revolved about the x-axis. You got to imagine this blue area being revolved about the x-axis. Now, first thing to realize here is the type of geometry we're going to get. If we take this area here and revolve it about the x-axis, we're going to get this kind of horn-looking geometry here. Now, in order to calculate this thing's volume, it's all based on the rectangles, the same rectangles you use for an area calculation. First thing we need to decide is whether we want to orient the rectangles vertically or horizontally. I'm going to go ahead and do the setup for either, or for both. I'm going to start with the vertical, and I'll go ahead and just kind of color code it here. All right, so in blue, if I draw a vertical rectangle like this, and I revolve that rectangle about the x-axis, what I'm going to get is a geometry that's going to look like a penny or a disc. So you got to picture this rectangle revolved about the x-axis. Now, if this distance is dx, in this picture here, that width would be a dx. The radius of this circle is equal to the function value here, which in this example is x squared. That will vary by example. Now what I do is we write a formula here for the volume of the disk. So the disk is going to have a volume dV equal to, now if I take that surface area and multiply by thickness, it becomes a volume. So that's going to be pi r squared dx. Now, the r is equal to x squared, so this is actually going to be pi x to the 4th dx. So here is a formula now that tells me the volume of one of these little disks. Within this volume here, you got to picture that's just like one of these. Now the total volume we get by adding them all up. That's what the integral does for us. So the integral pi x to the 4th dx, x is starting at 0, ending at 4. And this is a relatively simple integral to evaluate. So we're going to have pi x to the 4th integrates to x to the 5th over 5. And again, that's 0 to 4. So we end up with pi times 4 to the 5th over 5 cubic units. I think I'm just going to leave it at that. I think 4 to the 5th is probably 256, but I'm just going to leave it just the way it is. Right? Now, let's talk about what would this look like had we oriented the rectangles horizontally. So I'm going to go ahead and just leave the blue one there. Well, that may... Yeah, I guess I'll leave it there. All right. So now you got to imagine here in green here, rectangle oriented like so. And I'm going to separate this work off now. If we revolve this green rectangle about the x-axis, what we're going to get is a geometry. It's going to look kind of like a can. Very important to realize it's hollow. The can has a thickness, this dimension, equal to dy. It has a radius equal to this distance, which is our function value, which is equal to x squared. Now, if you took this can and I cut it and I stretched it out, it would look like this. Oh, you know what? We need one more piece here. We need this distance right here. So in this picture now, that's this distance. Now here's a very important part. From here to here is x, and from here to here is 4. That makes from here to here 4 minus x. So there's the dimensions of my can. Keep in mind it's hollow. Imagine cutting it, stretching it out. This distance is my 4 minus x. This distance is 1 circumference, 2 pi r. Now the r is equal to y or x squared. I'm going to go ahead and put x squared here because I think I'll just put x squared for now. And then it's got a thickness to it. I'll give it a little bit of a dimension there. You know, it's got a thickness dy. So this thing's volume dv can be written 2 pi x squared times 4 minus x dy. Now, you notice that there's both x's and y's in this, which is perfectly fine. There's a couple choices here. Choice number 1. We could solve for x. You know, this would be a y, and this would be a square root y, and then integrate with respect to y, which is perfectly fine. Or we can actually just shift this integral over in terms of x. That's no problem either, because dy dx is equal to x. Since y is x squared, dy dx would be 2x. We can solve for dy, no problem. Sub that there, integrate with respect to x. I'm going to go ahead and go with the standard method you'd probably see in your textbook, which would be to get rid of these x's. So let's see. We're going to write this 2 pi. Now x squared is equal to y times 4 minus x, and I'm going to get this from right here. X is equal to the square root of y, and then times dy. Our total volume is going to be now the integral over y. Now over x it was 0 to 4. Integrating with respect to y, the highest y point here is that distance, which is going to be 16. I'm getting that from the function value. So this is going to be integral 0 to 16. 2 pi y times 4 minus root y dy, which is going to equal 2 pi times the integral 0 to 16 of 4y, that's from this product, minus y to the 3 halves, that's from this product. And this is going to be 2 pi, and then y integrates to y squared over 2, so that thing's going to be 2y squared for this integral, minus y to the 3 halves integrates to 2/5 y to the 5 halves, and this is going to be evaluated 0 to 16. And what I'm going to do is just leave this as an exercise to the viewer here to go through and run that 16 through and make sure we get what we got before, right? The point of the video is the setups. So, you know, anybody watching this, what's really important here is noticing that if I'm using a vertical rectangle in blue, you got to be able to draw the geometry you get when you revolve that thing about the x-axis. Thickness dx, radius equal to the function value x squared. Set up your integral accordingly. And again, this thing's volume would be its surface area times thickness. If we use the green rectangle, I see I drew that past the 4 by accident, but went a little too far with that. Oops. If we use the green rectangle, revolved about the x-axis, we're getting a can-shaped geometry. And the really important thing is to go from this picture to this picture and get it labeled correctly. The thickness of the can is the dy. Again, that's that thickness. The radius would be this distance, which is the function value, y or x squared. Then the distance around is 1 circumference, which is, this distance is 4 minus x. And then this thing's volume is 2 pi r times the 4 minus x dy. All right, so I hope this video helps demonstrate how to set up these volume problems. Have a great day.